First step, take a capacitor, apply a voltage V, you get charge Q, capacitance is C. So once you charge it, then you disconnect the battery. A battery is disconnected, charge across the capacitor is same, capacitance as it is, there is a voltage across the battery, voltage across the capacitor, that is also V. Now, with the battery disconnected, there is some value of capacitance here, C is equal to epsilon naught A by D. There is some value of voltage also, there is some value of charge also. If you introduce this slab, if you push this slab inside, then what is the effect on various parameters? That is what we want to share. In sequence, number 1, capacitance. What is the capacitance in this case? First case, epsilon naught A by D. What is the capacitance in this case? C dash is equal to epsilon naught, yes, now you have introduced the slab, epsilon R A by D. So capacitance is how many times? Epsilon R times the original capacitance. So capacitance is epsilon R times. 1 minute to write. When you apply a voltage at 10 volt, there is some charge. So voltage across this is 10, charge is the same Q. Capacitance depends on area of the plates, distance between the plates, and material. What was the material here? Free space. That is why this value was 1. What is the material in this case? Epsilon R. That is why capacitance increases. Same result as in previous question, because capacitance does not depend on applied voltage. So capacitance is epsilon R times. First we will take up charge, not voltage. Charge. What is charge in this case? Yes, Q. What about this case? Anyone? Charge remains same. Why? Anyone? See, this wire, there is no way for this charge to move away. There is no complete loop. Circuit is not complete. If the charge on this is, say, 3 coulomb, if you introduce this one, this charge cannot escape because this root, this circuit is not complete. That is why charge remains same. Q dash is equal to 1 minute to write. For current to flow, what is the condition? Circuit should be complete. For charge to flow, condition is circuit should be complete. That is why charge remains same. Point number 3, voltage V. In this case, voltage V dash. Relationship, yes. C is equal to what? Q by V. V is equal to what? Q by C. Similarly, in this case also, V dash will be equal to Q dash by C dash. Q dash is how many times? Q dash is same. Q dash is 1Q. C dash is how many times? Epsilon R times. This Q by C is equal to what? So new voltage is, yes, 1 by epsilon R times. Voltage decreases. If epsilon R is 2, when you introduce the slab, the voltage reduces to half. 1 minute to write. Fourth, energy. Energy stored. 1 minute to try at your own. Energy stored. U. Try. 1 minute to try. Energy stored. Yes. Formula please. 1 by 2 CV square. Energy stored is 1 by 2 CV square. In this case, energy stored U dash is equal to 1 by 2 C dash V dash square. C dash is how many times? Epsilon R times. C dash is epsilon R times. Voltage V dash 1 by epsilon R V. What to get is, this is epsilon R, this is epsilon R square. 1 by epsilon R, 1 by 2 CV square is equal to what? U dash is 1 by epsilon R times U. That means what? Energy will also decrease. So capacitance is how many times? Epsilon R times. Charge remains the same. Both voltage and energy, they get reduced to 1 by epsilon R of a original value. Try numerical number 36. Numerical number 36 is, area of parallel plates of an air capacitor is 0.2 meter square and the distance between them is 0.01 meter. The potential difference between the plates is 3000 volt. When a 0.01 meter thick sheet of insulating material is placed between the plates, the potential difference decreases to 1000 volt. Determine part 1, capacitance of capacitor before placing the sheet. 2. Charge on each plate. 3. Dielectric constant of material. 4. Capacitance after placing the insulator. 5. Absolute permittivity of the dielectric. First decide whether it is a case of battery connected or disconnected. Go through the content. How? It is given in the question voltage, initial voltage. Initial voltage, charge Q, voltage V, capacitance C, energy stored U. Initial voltage V was 3000 volt and final voltage it is given. V is given as 3000 volt, V dash is given as 1000 volt. So definitely it is a case of battery disconnected because V dash is equal to 1 by epsilon R times V. What is the distance between the two plates? D 0.01 meters. Correct? What else is given? Area of the plates is given. Area of the plates is given. How much? 0.2 meter square. Distance between the plates is given 0.01 meter. First part. You have to find out what? Yes. Capacitance of capacitor before placing the sheet. C is equal to what? First case, yes. Epsilon naught free space A by D. Solve it. What is the value of epsilon naught? Yes. 8.854 into 10 raised to power minus 12. Area 0.2. Distance between the two 0.01. Calculate the capacitance. Find capacitance. Capacitance is equal to what? In farad. Yes? 1.7 10 farad. 1.7 into 10 raised to power minus 10 farad. Part 1 is answered. Second part. Charge on each plate. This was first part. Second is to find the charge. Yes, charge remains same. So you find in the first case or in the second case same value. C is equal to what? Q by V. Q is equal to what? C into V. Put value for C. Put value for C. Capacitance is equal to what? (1.7 into 10 raised to power minus 10). Voltage 3000. 5.1 into 10 raised to power minus 7 coulomb. Charge Q is equal to 5.1 into 10 raised to the power minus 7 coulomb. 3. Yes. Dielectric constant of the material, epsilon R. How you find epsilon R? What is the value of V dash? V dash is given 1000 volt. formula, voltage after introducing the dielectric slab is 1 by epsilon r. V dash is given as 1000. Epsilon r is not known to me. Original voltage was 3000. So epsilon r is equal to what? 3. So in this case, epsilon r was not known to us. Now you have solved. It comes out to be 3. Last part. Sorry, this was part 3. 4. Capacitance after placing the insulator. Fourth. Yes. New capacitance. Yes. What is the formula for new capacitance? Epsilon r times C. Epsilon r is how much? 3. What was the original capacitance? 1.7 into 10 raised to the power minus 10. Farad. Capacitance is 3 times. Last but absolute permittivity of dielectric. Yes. Point number 5. Absolute permittivity. Epsilon value is equal to what? Epsilon is equal to epsilon r into epsilon naught. Like in a density, density of any material is equal to relative density into density of water. This epsilon r gives you what? Permittivity of a material is how many times permittivity of free space, relative permittivity. It is a unitless dimensionless part. Epsilon naught gives you what? Permittivity of a free space, 8.854 into 10 to the power minus 12. Epsilon r is equal to what? 3. Find epsilon is equal to. Find epsilon is equal to what? 1 minute for calculation. Yes? 2.66 into 10 raised to the power 10 raised to the power minus 11 units parameter. Farad per meter. It should be farad per meter.